In 2020, while humankind was battling a pandemic of global proportions, agricultural industries simultaneously battled a different outbreak, that of African swine fever, or ASF, which has caused a great impact on the Philippine economy. African swine fever, or ASF, is a porcine disease mainly caused by a DNA virus and is a highly contagious disease of pigs, European wild boar, American wild pigs, and warthogs. African swine fever was first reported in the Philippines on July 25, 2019. Since then, many ASF outbreaks in various regions in the country have caused the culling and death of 3 million hogs, thereby causing more than 100 billion pesos in losses and a spike in inflation. As of today, prevention and control of the disease is mainly based on its early detection by laboratory diagnosis, followed by strict sanitary measures.
Livestock, like pork meat, is one of the major product line here in the Philippines in terms of protecting our economy. So the livestock industry is also being attacked by another form of pandemic. So for us, in keeping with our goals to help the country through development of diagnostics, we wanted to have our own versions of the African swine fever PCR kit that will help in the surveillance, monitoring, detection, for immediate control and prevention of spread. So the African swine fever kit is one of our contributions as a team of scientists from Manila Health Tech to help control this epidemic going on in the country.
For the development of our ASF PCR detection kit, we started by selecting primers that would detect two genes. Gene PEPA codes for a protein that is dominantly found in ASF-infected pigs. Gene PIGGY acts as an internal amplification control to confirm successful isolation of the biological material. The primers and probes for both genes PEPA and PIGGY show high specificity to the target sequences present in the NCBI database. Molecular-based protocol development is principally divided into two major phases. Phase 1 is the protocol optimization and laboratory performance validation based on standard sets of criteria. Phase 2 is the field performance testing that determines the behavior of the molecular-based protocol when already performed in an animal testing laboratory setting. Inter-instrument variability was conducted using two different PCR machines run by the same operator.
Precision can be determined by repeat testing of samples. We consider precision at two levels: repeatability and intermediate precision. The analytical sensitivity of an assay is its ability to detect a low concentration of a given substance in a biological sample. This type of sensitivity is expressed as a concentration, for example, as copies or genome equivalents per unit of sample material. The optimized kit was then sent to an independent laboratory for external validation where ASF samples of known identity were tested, all of which were successfully detected by the kit.
The good thing about the GenAmplify African swine fever PCR detection kit is when it was evaluated by an independent animal testing laboratory here in the Philippines, it showed a diagnostic sensitivity of 100% and a diagnostic specificity of 100%, making this technology at par with the global landscape in terms of diagnostics for African swine fever. On top of that, because it's locally made and the development and manufacturing is done here in the country, it's also one of the most affordable molecular diagnostic tests for African swine fever here in the Philippines. So this is what supporting local technologies is all about, to make it more accessible to more Filipinos in need of important diagnostic tests. So competitively, it is at par with the rest of the global diagnostic armamentarium for African swine fever. So we're very excited about it, and we're very proud of what we actually put together for the country. Thank you.